Hello, everybody. So this is the lecture for week 11, and we're going to be going over some of chapter 6 in the Zybooks. Uh, there's going to be some stuff pushed off into a second lecture this week. That's going to be some of the stuff that's in chapter 5, actually. So you'll have to kind of go back and look at chapter 5 in the next lecture. And also, we're not going to talk about transistors in this lecture at all. So we're just going to kind of skip that in the Zybooks. With that said, let's just kind of jump in. So I already have Zybooks open to 6.1, and they're going to teach you about AND gates, NOT gates, OR gates, those sorts of things. But in addition to giving you the truth tables and the symbols, which we've covered plenty of times in lab, we they also have pictures of it in transistors, and that is what we're going to ignore. So I recommend that you kind of don't pay attention to that for now until we have a lecture on that, which will be the next lecture. So with that said, we should know the truth table for the NOT gate, where if it input is A, the output is 1. If the input is 1, the output is 0. And we should know the symbol for a NOT gate. And then we should be able to answer questions like these. They're already answered, unfortunately. If the input is 1, NOT outputs 0. If the input is 0, NOT gate outputs 1. A NOT gate is called an inverter, not an oppositor, but you know, oppositor sounds nice, but not the word. Um, and then we get to the AND gate. So the AND gate truth table we should also be familiar with. So an AND gate, which has this symbol, has two inputs and an output. So you need to know the inputs A and B, both of them, before you know what the output is. And we can see that when the inputs A and B are 1 and 1, then the output is 1. And every other combination gives you a 0. So basically, if you have a 0 anywhere on the input, you get a 0 on the output for an AND gate. So a 0 and a 0 give you a 0, a 0 and a 1 gives you a 0, a 1 and a 0 gives you a 0, only 1, 1 gives you 1. And then we have over here what it looks like in transistors. So the questions are going to ask us some stuff about that, but we're going to just click through them for now or ignore them for now. So they're talking about, does H conduct, does J conduct, does I conduct, does K conduct? That's going to be based on the values that you see next to the transistors. And we just haven't gone over it yet. So you can click through them and get the answers, but we are not um, going over that in this lecture. Okay. So I don't know what we're doing here. Click inputs on the left side to observe the output. So this is just trying to figure out what an AND gate does. So I guess if I click this and make it a 1 and a 1, then the answer is 1. But if I do a 1 and a 0, so the one that's dark is the one that's selected. So 1 and 0 gives you a 0. 0 and 0 gives you a 0. 1 and 0 gives you a 0. 1 and 1 gives you a 1. Uh, Same thing for an OR gate here, where this time with an OR gate, 0, 0 gives you 0. Every other combination gives you a 1. So if there's a 1 involved on the A and B, then you're going to get a 1 on the output for an OR gate. So 1, 1, 1, 1, 0, 1, 0, 1, 1. But when you have 0, 0, you get a 0. Now, similarly to the other one, oh no, actually, this does not ask about the circuits here. So if A is 0 and B is 0, what is T, the output of the NOR circuit? There's a NOR circuit. Um, oh, T. So they're just using different terminology from the last one. So if A is 0 and B is 0, what is the OR gate output? 0. If A is 0 and B is 1, What's the output of the NOR circuit? Not NOR is not OR. So without knowing anything about transistors, you can go to like number 4 and it says if A is 0, B is 1, what does the OR gate output? We know that 0 or 1 is 1. And then you could, after you know that, you can go back a step and say, well, the NOR would be the opposite. So it should be 0. But again, we're not talking about transistors in this lecture, so that's kind of avoiding those. So you click on something here, get the credit, and we got our 3 logic gates. So if you put a 1, 1 there, you should get a 1 because that is an AND. This is a NOT gate, so you need to recognize the symbol. So 0, not 0 is 1. Recognize this as an OR. 1 or 0 is a 1. Then they have 3 input versions of these. They work the same, like the same rules. So like if you had a 1 involved on the input of a 2 input OR, you'd get a 1, right? So any ones over here would mean a 1 over here for an OR. So this should still be 1. Same thing here. Any ones over here should result in a 1 over here for an OR. And for an AND, all of them have to be 1 in order to get a 1. Another way to say that is if there are any zeros over here, we should get a 0. And there is a 0, so it should be 0. Okay. So indicate which logic gate is best suited. If either of the 2 windows is open, an alarm should sound. So the signal is 1 when the window is open. So if there's any ones over here, we want the alarm to sound. So if there's a 1 here in window 1 or a 1 on window 2, we want an alarm. So that should be an OR. A plane enables its engines. As long as both pilots are seated, then we enable the engines. So you need both. So we need a 1 and a 1. So that's an AND. A sensor detects sunlight. 0 is no sunlight, 1 is sunlight. A lamp should turn on only at night. So if there's sunlight, we want no lamp. But if there's no sunlight, we want lamp. So if sunlight is 0, lamp is 1. If sunlight is 1, lamp is 0. So that sounds like a NOT gate. Disneyland's Little Mermaid ride outputs a stop signal if a person is detected on any pressure-sensitive mat next to the ride's cars. So if it's anybody, like one person can make the whole thing stop, that means it's person 1 or person 2 or person 3. They could all stop it, and that's an OR. The car has pressure sensors in each tire. If the tire's pressure is low, a warning light should illuminate. So if any of them are low, we should get a warning. That's an OR. Office has 4 space heaters. The office electrical system can only support 3 being on at one time. An alarm should sound if all 4 are turned on. So all 4 would be heater 1 and heater 2 and heater 3 and heater 4. So that sounds like an AND. Okay. The activity failed to load. Try reloading. I've never seen that. Have you seen that? Oh, there it is. So this is going to be relatively straightforward. So you just look, that's a 0. That should be a 1. That's 0, 0, and sounds like a 0. 1, 1, and this is an OR, should be 1. Cool. Let's skip to number 3. If the output is 1 and this is a 1, then this should be a 1, right? It takes a 1, 1 to get a 1. Go ahead. We got 3 here. So the output is 0, which means we got a 0 over here, right? But we can see that we do have a 0 over here already. So that means if there's a 0 in the middle spot, the output will be 0, no matter what. So it actually doesn't matter what A and C are. we're going to get a zero. So when it says what are all possible values for AC, well, A could be a zero and C could be a zero, or A could be a zero, C could be a one, or A could be a one, C could be a zero, or A could be a one, C could be a one. All of those combinations for A and C will result in a zero because of this zero. Okay. Similar here. So the output is a one, which means there's got to be at least one over here. Since we see that there's a zero, that means we need at least one out of these two. So you just need to list all the combinations where at least one of B and C are one in order. So that'd be 0, 1, or 1, 0, or 1, 1, I think. There we go. Cool. So this stuff we've been doing for a little while, right? Boolean algebra. They're going to start easily, I think. Um, so H, hungry, S, sleepy, M, mother, C is baby will cry. So baby will cry uh, if it's hungry. So cry equals H. A baby will cry if it's hungry or sleepy. So we're looking for hungry or sleepy. There's hungry or sleepy. Baby will cry if it's sleepy and not being held. So that sleepy is S, not held is not S. So, oh, S and not M. Oh, we I said S and not held by mother was M. So that's a S and not M. So it's this one. Hungry and sleepy. It's hungry and sleepy. Baby will always cry. Cry equals true. Cool. So indicate whether this is correct. Car will start, so that's C. Only if battery works, so B is battery works, and there's enough gas. Well, it says and gas, battery and gas, but this is battery or gas, so this is no. The car will never start. So that's car start equals false. Yeah. The car will start if there's enough gas. The battery doesn't matter. So car start equals gas. Yeah. The car will not start if there's not enough gas. Uh, this was car start, and this is not gas. So this would be saying that the car will start if there's not gas. It's supposed to be the car will not start if there's not enough gas. So this is like the opposite of what it's supposed to be. Cool. So these are relatively straightforward here. So, I mean, we can do maybe just not all of them, but like A is false, B is true. What's A and B? False, right? Um, we'll do this one. A is false, B is true. So this is false and actually we don't even need to read any farther because if you have a false and, it's automatically going to be false. Not A and not B. Well, not A is true, not B is false. So not A is true, not B is false. I think I got that right. So one of them is false anyway. So we have a true and false, which is false. Um, alrighty. Boolean equations, we've done all this stuff, right? So we've seen that rather than writing and or not, we write multiplication, addition, and we can write an apostrophe. Um, you can also write a line over it, as we've seen. What are we doing here? Translate each operation to an expression. So A or B, right? So they want us to use pluses and multiplications. A and B. So that's AB or C. Don't really need the parentheses. Not A. That's an apostrophe there. Not A. and B, so we multiply them, not A and not B, and is multiply not AB. So there you'd have to put the AB, and then the not has to be on the outside. It's important to understand that this not AB is not the same as not A and not B. All right, not A or B. A plus B is A or B, and then not on the outside. Cool. Um, I feel like we're good at these, so I'm kind of don't want to do too many, but let's see. D is door open, W window open, E arm alarm is enabled, N nighttime, S alarm. So let's see. Sound the alarm, so they're all S. If alarm is enabled, that's E, and window is open or door. So that's E, window or door. So it looks like this one. And from the way that they worded it, they made it sound like the alarm has to be enabled and then there was a choice of two things, an or, window open or door open. So enabled and then window open or door opened. And so you just have to understand that that's that and not like that, based on the wording, I guess. So what do we got? Sound the alarm if the alarm is enabled, and so that's E time something. The window is open at night. So if the window is open at night, that means the window is open and it's night. They didn't say and, but if they said window open at night, that means window open and night. So that's WN. So alarm is enabled and window is open and it is night. So that's actually the top one. Cool. So functions. So the thing about a function versus an expression is if you write something like these up here, there's no equal sign. So those would be called expressions, right? And that's just how you've always done math. Expressions are just little bits of math with pluses, minuses, times, that kind of stuff, but no equal signs. As soon as you add an equal sign, you could call that a function. So these are called functions, even though they're not listed that way. And then here they're saying, if there's no equal sign, it's an expression. If you put an equal sign, it's an equation. That's true. And then a function, it says, relates input values to output values. They say, oh, you could write it as an equation, but there's also like the table. If you write the table or the circuit, that could also represent the function. So, technically an equation is just an equation, but an equation like this, where you have variable equals, that's a function, but it's only one of the ways to write a function. So they're saying functions could also be various things, including an equation. When you get down here, is this a function? No, because it's just an expression. Is this a function? Yes, it's an equation, but an equation should be a function. Is y equals c plus d an equation? Yeah, it's that too. So like it can be an equation and a function. Does this represent a function? Sure, right? We have two input variables, c and d, and an output variable, y. Is the following a function? Y is 1 if either or both of c, d is 1, else y is 0. Yeah, I think that describes the whole thing, right? Like you'd be able to fill out the truth table from it. So I think that's okay. Is this a function? Probably. I didn't read it. Let's read. Output y is 1 if both inputs are 0. Otherwise, y is 0. Also, if both inputs are 1s, uh, y is 1. Okay, so they just describe this in a way that doesn't make sense because here it says output y is 1 if both inputs are 0. Otherwise, y is 0, right? So they already told you otherwise y is 0, but then they kept explaining also if both inputs are 1, y is 1. But if both inputs are 1, then that should have already been covered in this otherwise. So this doesn't make sense. Like there's no way to actually write this in a truth table because you'd have to fill in the you'd have a box that has to be filled in with a 1 and a 0 because they said contradictory things. So that's what I get for clicking yes without reading it, but that's a problem there with it. Is the following a function? Output y is 1 if both inputs are zeros. No, it's not a function because they didn't tell you what happens in the other cases, right? It has to be complete. So as you can see here, cool. So we already know this stuff, right? Equation to circuit. So like we see A or B, so A, B, or. We see C and not D. So there's C and then we have D going through a not. So that's not D getting in here. Yeah, there you go. So these are relatively straightforward, I think. So it says like use the figure above to determine the missing value. The original equation is IJ plus M not N. So we have I and J, I and J. So here's I and J, and it's I and J, right? Because multiplication. So that means that this should be an and. B, where's B? Over here. So these are the other two variables, right? So I and J are up here. So we have M and N. These must be M and N, but specifically we see not in, right? Not in. So here's a not. So this must be in, right? So in goes through the not gate. So that's got to be in. C, well, if this one's in, this one must be M. D, these two things are anded together, so this must be an and. And then finally, the output of I and J, the output of M and not N, should be ORed, right? The plus is an OR. So this is an OR. Cool. So let's see. What if, what is H if a heartbeat is detected? Okay, well, we're reading the picture here. What is H if heartbeat is detected? H equals 1 if heartbeat is detected. Right? Reading. What is W if the sensed weight is 30 pounds? W. 1 if weight is greater than 60. So if it's only 30, then it won't be 1. It must be 0. What is E if H is 1, W is 1, D is 1? So H, W, D, all 1. So if H and W are 1, we've got a 1 and a 1 here, right? 1 and 1. Oh, actually, we got the equation here. E equals HW, not D. So if you have H1, W1, D1, then this is 1, 1, not 1. So the not 1 is going to be a 0. So this is 1, 1, 0. But 1 and 0, as long as there's a 0 involved in an and, the result is going to be 0. So the airbag is not going to be enabled. We're going to get a 0. Okay. E becomes an input to the airbag deployment system. That system has another input to detect a hard front-end collision, C equals 1. That system's output should be a 1 if a hard collision is detected and the airbag is enabled. Write the equation for A. Um, A equals hard collision, which is C, and enabled, which is E. I don't know if they want us to substitute in what E is or not. No, they wanted that. That's fine. Write an equation to deploy the airbag. So that's going to be like A equals something. Only if a collision is detected, that's C, and the airbag is enabled, that's E. Oh, and then it says use the input variables H, W, D, C. Do not use E. All right. So yeah. So we already know that E was listed here. E is H, W, not D. So we have get rid of the E and put H, W, not D. Now the problem with this is it says order the inputs alphabetically. So we got to move the not D here to next to the C. So C, D, H, W. That seems fine. Okay. A light illuminates if the airbag is disabled. What is the appropriate equation to turn on the light? So, uh, airbag disabled. So we want the opposite of this. So HW not D, and then the whole thing with a not. HW not D, and then the whole thing with a not. That's not the same thing as just reversing all of the, not the same thing as reversing all of the inputs. So the parentheses and the not on the outside were important there. All right, I'm going to skip down a little bit. Circuit to equation. Oh, combinatorial or sequential. Uh, okay. So surprised we've got this here, but combinatorial is like what we were doing up above. Okay. So we're looking for a combination of input values. So all of these up here were combinatorial, like what is C, what is D, what is H, what is W, and that tells you the A, right? Um, that's combinatorial. A sequential circuit is when you have like a bunch of steps in order to do something. So you have to do the first thing and then do the second thing and then do the third thing, right? There's like an order to it. It's not just based on the combination of input values. So if it says like if one or more people are in a room, turn on the lights, that's like what we've been doing, right? Says if the weight of an elevator exceeds 1,500 pounds, sound an alarm. That's like what we've been doing, right? Now, this one says if the sleep mode button is pressed and released, turn the phone ringer off until the sleep mode button is pressed again, right? So that's like time is happening here, and we have to do things like we have to do something now and then wait and then do something. Uh, that is not combinatorial anymore. Turn on faucet when motion is detected. That's like what we've been doing, right? If the garage door button is pressed, turn the motor on until the garage door is fully opened. Technically sequential because you have to turn the motor on and then off. Um, all right. What is this? Oh, cool. We get to draw circuits. Add a gate to a workspace. Oh, how do we do this? Let's find out. Z equals B plus C. So B plus C is a or. So we just put this. Do we, oh, oh, check. Amazing. That works pretty well, actually. Let's go to number three. Not A, B. Okay, so we have an and. We also have a not. So It's not A, so A needs to go to the not. Oh, then the not needs to go to one of these. B needs to go to the other one, and that's the output. Boom. So these are relatively straightforward. How bad did they get? Let's go number six. Oh, they're not that bad. Um, all right. Oh, they're a little bad. So when I do these, right, the overall structure is an or, right? It's something or something. So I'll put the or like last, and we can even connect it, right? So just like put that there. Um, so that's the or. Then we have A and B. So let's get an and let's do A and B. So that's the second one here. Now we need to do not B and C. So we need another and. The C is easy. What we need to figure out is how to get the not B, right? So we need a not, first of all. And then we need to get the B to that. So I guess like this. Okay, that works. So B not, there we go. Yeah, it seems fine. All right, that's not so bad. Let's go 6.4. So these are helpful for figuring out how to do the drawings. So these not gates, remember in lab a number of times I've said technically it's the circle that means the not, and the triangle is just so you have a place to put the not on it. So they do kind of get rid of that triangle. And so like if you put a circle there, that would mean not be. So that's useful to know. Also, when you're drawing circuits, it's hard to draw them without crossing lines, right? So what they do is by convention is if they put like a solid dot here, that means that actually like the three wires that you see around the dot, those are all connected. But if you see something like right here, where the B goes this way and then the C comes by it, if there's not a dot there, that means actually this wire and the tall wire are not connected. So you have to put a dot to indicate that they're connected. And that's just kind of the way that people do things. This doesn't make sense. You can't hook a and a B up to one wire without like a gate, right? Like A and B hooked up to the same wire is not a thing. We've never seen this. That doesn't correspond to like an equation or anything. But you can split a wire. And in fact, in the exercise we did at the end of the last section, we had a B and a not B, and that involved kind of splitting a wire, right? So you can't have two things come into the same input, but you can split an output into two things. Okay. Yeah, sometimes if you don't want to draw this first one where like the A comes off, you can just be lazy and just write A twice just to make the drawing easier. That's okay. Gate inputs are not labeled. Yeah, they usually don't do that. Um, okay. Do these connect? Yeah. Do these connect? No. What is this? J, K, not K, and. So J, not K. This is okay? Nope. This is okay? Yeah. Label Y is normally used for the gate output. I think that's the last thing where they say gate inputs are not labeled. So they don't normally don't do that. But all right, algebra. We've done this too, right? We've done this a couple weeks ago. So all this stuff is so easy, right? Um, Actually, I remember people doing these last semester, and they're maybe not quite so easy. So, but what they want you to do is kind of you have to go through algebra steps here. So, like let's say we had this expression right here. So it says original expression. So this is it, which is right here. So that's the original expression. And then it says a complement. So I think they're referring to identities. So like the identity that we would do is like D plus not D, right? Remember that that always simplifies to a 1. And if you compare this to this, you'll see it's the same, except the D plus not D has been replaced with a 1. And then it says identity. Well, if you do 1 and something, you don't need to write the 1. So this compared to this, they've just stopped writing the 1. And then this D, not D, can be distributed and it'll look like this. Okay. So you can change the order of things in and or. Uh, A or 1 is automatically 1. We've seen all these rules, right? We had them in a lab earlier. Let's see. Original expression. So the original expression's the long one, looks like this. Null elements. Null elements, they're saying, is when you have a 1 or something. That's what they're calling it. So this is a 1 or something, and it just simplifies to a 1. So we look over here and I see it. There's a 1 there replacing that. So that's where they applied that rule. Then the identity 1 times something. You don't have to write the 1. So it'll be this one. Wait. Yeah. I'm like, what's the difference between these two? The difference is the order that they wrote the F and the E. But this is the one that matches this. So this is the correct one. Then they said commutative. So commutative is being able to change the order. So they decided they wanted to change the order of F not E to not EF. Okay. And then they said idempotent. So what's the idempotent law? Let's go find it. So the idempotent law is A plus A is A times A is A. I mean, technically or and, but A or A is A and A is A. So here they've got not EF plus not EF plus not D. But there's two not EFs. You don't need both of them, so you can just drop one. Cool. All right. So I think this is, you have to do the steps by clicking on things. So we have to be careful here. So I already started it. So it says simplify this to Y. So we're here. So what identity should we apply? Well, the way to simplify this is the W plus not W should simplify to a 1, right? So you look for that rule, and they're calling it complement rule, right? A plus not A is 1. We need to do that for the W. So we should click here. Okay. Um, check. Okay, hold on. Let's figure, I don't know how to use the tool. Uh, let's see. Select a property, apply the property to your expression. Okay, let's try it again. I want to try it again. Next. So here's our expression. So we click the property, and then I think I click on the W plus not W. I'm going to click it. Oh, okay, never mind. I'm going to restart. So once we've selected this, you see it's highlighting the A. So you click the W, uh, and then I think we click the not W, and then we click next. No, okay. We're gonna do it over again. I'm gonna do it right this time. I promise. I don't promise, but I think I can do it. I think. Wait, where is it? What were we? Okay, were we done here? We were all the way down. Oh, we were here. Okay, we're gonna get it right. Okay, Y or not Y? Click the rule. A or not A. Click it. Read this. Select the A from A plus not A. So that's the Y. Then I have to hit next. Then it says select not A from that expression. That's the why not. Then click apply property. Boom, we did it. Okay. Now, what do we need to do next? We're trying to simplify it to W, right? So we don't need the one. So I see that that rule is called identity, right? A times one is A. So I click that. Then it says select A from A times one. Well, it's W. So we click that and we click next. Then it says select one. So click the one and then apply. Okay, we did it. Whew. There's more of these down here, I think. Whew, let's try this one all the way down here. Start. So what property do we want to apply first? I think we want to factor out a y. So I look over here for where do we factor out a y, and I see that that's the distributive law here. It's like technically the distributive law backwards, right? AB plus AC, factor out the A. So this is the rule. So then it says select AB. So that's the entire first term. So we select this, click next term. Then we want the AC, that's the second term. And then we apply. Okay, we factored it out. Now we have not X or X. So that's the rule down here that they're calling complement here. So we find the right rule, complement, click it. Then it says select the A. So that's, I don't know if it matters if we select the first thing or the second thing here. I guess we'll find out. Because technically A and not A doesn't matter the order, right? So I'm going to try this. I'm going to click the first thing here to see what happens. And then I'm going to click the second thing and see what happens. Yeah, so are they really going to make us do that? I'm going to try it again. We'll do the commutative law if we absolutely have to, but select A. Try that. Select not A. That. Ah, okay. So they're really telling us that this is not X or X, but like the not is on the left instead of the right. They're really telling us we have to flip it around the other way. So to flip it around the other way, we have to do the commutative law. So click the commutative law, select the first term, select the second term. Now it's flipped it around. Now that it's X or not X, now we can apply the complement rule. Select A, next term, select not A, apply. There. Then we have to get rid of the one. So that is the identity law up here. So identity law, select the A, it's Y, select the one, it's one. Okay. Fun. Jump into three. Oh, geez. Okay. So what are we doing first? Um, okay, on the first one, I can apply the distributive law and factor out an X, right? Distributive law. Boom, boom. Okay, we did it. Let's do another distributive law. I don't think it makes us do it in a particular order. So let's do another distributive law on the second thing here, because we got these not W, not W's. So let's do it again. Distributive law. First term, second term. Okay, cool, we did it. Now I got Z or not Z, and I've got X or not X. So we can apply the complement. Also, they're in the right order this time, so I don't have to flip them around. So let's click that. A, next, not Z, apply. Let's do it again for the other one. X, next, not X, boom. We did that. Now let's get rid of those ones. So the ones are the identity. So identity, click the X, click the one. Cool. Do it again. Identity, click the X, click the one, not X. Boom. Cool. So once you learn how that tool works, it's actually not that bad. It's just what you click, right? When you click it. Okay. So I think we're going to stop here. But this stuff here is also doable. This is similar to what we've been doing in the lab, right? So you'll probably be okay here. Good luck. I'm going to stop for this lecture right now because I'm out of time. Talk to you guys later.